Hello there. Today we will be doing a number of sublist with sum of target. Given a list of integers nums and an integer target, return the number of sublists whose sum is equal to target. Okay, so in this example here, 2, 0, 2, we have a target of 2 and we have an output of 4 because we can create these 4 sublists. So one thing we might be thinking right now is that why don't we just create a sliding window and just grab items until it's it's a 2 and skip items that until it goes over 2. The problem with that is that what if like there are items like a -2? Well, that just brings us back like this 4 here minus the 2 is a subarray which gives us a 2. We can't handle that if we remove items above our target. So we can't do that. We can't do a sliding window. That's not what we're trying to do. We will need to take every item, brute force, and check like every subarray. And this is the n squared method. And we have to sum it. That's n to the third. So, but what kind of information can we get from this being a sublist? Well, the information that we can add to this this particular problem is adding the sum, like the cumulative sum. And the cumulative sum of 2 plus 0 is 2, and this is 4, and this is 2, and this is 0. So how is this cumulative sum at all useful? Well, because this is a sublist, and all items must be created from prior items, we can find out from what prior item can we get to our current item. So as you can see here, this particular 4, we can get here from either 2 or 2. We can get there in 2 ways. So we can get there. This is one way to get to. This is another way to get to, and this is 2 ways to get to. And this is how many ways can we get to this 2? Well, there's a 2, so there's 1 way, and there's a 0. So 0. If we had a -2 in our setup, like we can somehow get to a 2. And that would be another 1, but this is 0 here. So this would be a total of 5 ways, and we should return 5 if this is the case, right? So a lot of these times this is like adding more information to our particular problem to get a faster solution. Then the reason why this piece of information can be added is that there is a sublist, and this is how how we can build up our answer. All right, how do you get creative enough to figure out these solutions? I have no idea. I looked up the solution and asked questions, and I'm not quite sure where the creativity comes from. Maybe it's understanding prefix sums, maybe it's understanding the idea of sublists. Just having all these ideas, patterns inside your head and being able to pull them out. Man, I have no idea how, like what sort of training or sort of like, intuition that came into to get this idea, but this is what I see at this point. And if I ever see a sublist again, maybe think, oh, let's try a prefix sum. Okay, so let's get this. So first of all, we need a hash map to store how many times we've seen the previous item, because we're gonna add all the items up until that point to get that particular spot. And then we're gonna need the count and the cumulative sum. Cumulative. Let's just get this. Then, of course, we can do for num in nums. We can just create the cumulative sum. plus equals num. Then if the cumulative sum is equal to target, then count plus equals 1. Otherwise, if the current sum minus the target is in the hash map, actually we don't even need that. We can just do counts plus equals hash map of the current sum minus the target to get a previous item that is of the target, like I said, 4, and you see 2 2s. And with that, we can add the item to our hash map. So hash map of the current sum minus, the target, the current sum plus equals 1. The thing is, we can even like make this more and more, how do you say, like short in code, but it's gonna be like more and more messy. You'll see what I mean soon. So let's get this running first, and we'll start tooling around inside this code. Looks like current sum is not, it's cumulative sum. I don't like long, looks like I don't like long items. So as you can see here, this is how we have done it. We're gonna add to the if we found the previous item, then we're gonna add it to that particular item to our count, and we're gonna add our current sum, cumulative sum, into our hash map. Thing is, we can even do this. So count plus equals this particular thing here, because this is either going to be E0 or 1. So this is like, let's see it, let's run it and submit. It looks like it worked again. Let's see if we can do anything else. Nope, I think that's as simple as it gets. But it is less descriptive. Let's make this as descriptive as possible, so we can, the reader will be able to understand this code reading it next time. So I think that's key. We don't want to write code for the computer's sake. We're writing code for other people to read, and that's what is important. And I think this line of code here, like, let's just give this a variable. So like previously found, like contingent, let's say something that we can build on to get a difference of 2. Pass sum, or let's see, not previously found, if a cumulative sum minus target in hash map. That tells us that, oh look, we have seen this before. Seen sum. Let's just say seen sum is equal to, so if seen sum, like if it's seen sum is inside our hash map, how do you say, precarious sum, no, found sum, a parent sum, yes, a parent sum. If this parent sum is inside our hash map, that means that with that parent sum, we can get to our current place in the hash map that requires 2, because this is 2, right? If we lose this part, we can get a 2. If we lose this part, we can also get a 2. It's about how many parent sums are there. So some count, maybe, like how many times they're inside. I think the count part's a little extra. I think that is good. I think that will give us our best, most information written into the code for our next reader to read. And if you have any suggestions, please comment below. If you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. I'll thank you very much, and I'll see you in the next one.